Um, I think the first thing that I kind of owe to everybody is a brief walkthrough of the syllabus and that kind of thing. It's nobody's favorite part of any class, but it's kind of necessary. Um, all three of you have at this point like registered for the class, correct? Yeah.
Should
Okay.
be,
Yes.
yeah.
Okay. So the class homepage should be deployed, and I'll go ahead and share my screen. Um, Here we go. Okay, so here we are on, you know, quantum mechanics 2. Here are my office hours for now. I may change those office hours as the semester goes, and I may, for example, alter them in such a way that I have like a virtual office hour, for example. You know, in your case, Nathan, you're going to be traveling a lot this semester, you'd said by email. And so it may be that I create a different office hour time that is my special, like it's there virtually, um, and maybe like let the other two of you guys know it as well. But that way, like you have some office hour access, because I've found in practice that, uh, well, for one, that I never know what office hours people end up wanting to use and don't, but that I tend to have boom and bust hours. So I have one set of hours that people are just like, no one shows up and it's crickets chirping in here. For the entire semester, one person may show up at that time. Then I'll have other hours where it's like 8 people here at a time for the entire hour. And so I want to, if I do a virtual one, have one that works basically for you three, especially for you, Nathan, because the other two can, you guys could show up at any office hour anytime and get what you need. But preferably one that I don't have lots of traffic here, because it becomes very hard to have a virtual office hour when there's live people.
Right.
Okay, so that's item one. These right now are like my official hours. And if you look at those, the two of you that are on campus now, if you were to come by and look at my door, there's schedule posted there. It has these hours, but it has other hours, that kind of thing. Don't worry about all the other hours. Those are like, I may end up having office hours that time. They may end up being online office hour or virtual hours. They may end up moving around with stuff that says prep time or service or whatever. Okay. So that's item one. Item two, the announcements. I'm not going to have many announcements here, but there will be occasional ones. Uh, for example, one thing that I am facing in the next week is I've been summoned for jury duty to the district, the federal district court for Middle Alabama, which is in Montgomery, for what it's worth. So I'm supposed to report on Tuesday. Now, you know, I'm assuming that it'll be like all the other jury duties I've ever been summoned for, which so far is one, where that day they're just going to put us all in a room and ask us a bunch of questions and figure out whether they actually want us on the jury or not. It is for a grand jury and it is for a federal court as opposed to the local district court. Don't know how that affects stuff because I've never done it for federal. Hopefully, um, either I end up not being selected finally, or if I do get selected, it's like one of those short trials that's a couple days, not 2 weeks, because it's from 9 to 5 for those, however long the trial runs. And if that happens, then we will very obviously be doing this after 5. I will be exhausted from a day of listening to whatever we have to listen to at jury duty, but we'll try to do this afterwards, and I'll keep you guys posted. All right. Hopefully this is a big nothing burger, as the saying goes, but you never know. Um, so if if I find out that I'm going to be on jury for 2 weeks, I'll have an announcement here saying, "Yep, I I'm stuck on this grand jury. They let no one go or whatever." Last time they told me to stop answering questions midway through. They got sick of my answers and said, "You're not on the jury."
That's perfect.
But they didn't let me go anywhere. I had to just sit there while everybody else answered questions. So we'll see. Syllabus is posted. Nothing changes here, whether we're whichever of those three options we take. This stays the same. Um, this is mostly like the regular boilerplate. Like, look, all of you guys know where my office is. All of you know my email. All of you know who I am. All of you have had a few classes with me, except for Nathan, who's come to hang out at my office a couple times anyway. There's not much to say here. Um, Obviously, prerequisites, quantum mechanics 1, um, which is the version that Chip and James formerly took. And for you, Nathan, you have seen the videos for it. So you basically have the story of what it is that Chip did.
Mhm.
Because those were last semester when Chip was taking it. James, of course, took it um, during an off semester,
Okay.
last spring, as it turns out. But it's the same set of notes that all of you should have. We all got to the same part of the book, which was basically through chapter 5. So we're starting this semester chapter 6. I do think the chapters are a little longer and the materials a little harder, starting somewhere between 6 and 7 for what it's worth. But it's not like insane. I wouldn't call it insanely hard versus easy mode or whatever. Like on a scale of, let's say, like 1 to 10, where 1 is physical science and 10 is graduate E&M.
Mhm.
Quantum 1 probably rates about a 5 or 6, and Quantum 2 probably rates about a 6 or 7, in
Okay.
my humble opinion. I think that like E&M, undergraduate E&M, is probably a more difficult course than this one. I think classical mechanics is maybe slightly easier, although if you took it from Dr. Bankert, it's probably about on a par. Um, it's by no means meant to be the most difficult course that you take as an undergrad. And it's certainly not going to be more difficult than stuff that you'd see if you went to graduate school and did physics in grad school. Okay. I'm teaching it at what I think is advanced undergrad level because that's what the course is. We are using the same book as all of you used, or in your case, is what you have on your desk, the McIntyre quantum mechanics text. Mine, of course, is the Pearson version. It's now actually by Cambridge, but it should be the same text. Um, so that, of course, is in here. There's some, you might want to supplement a little bit with, for example, like your physics 1 and 2 texts. Occasionally we do stuff that refers to things that we did there. Quantum mechanical harmonic oscillator. It has the same basic potential function as a spring, like a weight on a spring. It's just that now we're doing it in Hamiltonian language and the solutions that result from it. Um, I would recommend, probably a good idea to have a good as reference math methods book. And I don't think I've seen any one that I'd say like this one is the gold standard or this one is not any good. The one that I learned on is up here. I can't quite get my hand on it because it's thick. This is the one that I learned on, but we used a different one here at Troy and should be just fine. They largely have the same. Yeah, should be fine.
Yeah.
They largely tend to have the same story. It's like, here's a discussion of complex analysis. Here's a discussion of series solutions to stuff. Here is Taylor expansion. Here is some basic types of integrals that you might see. It's etc. Differential equations. That's all nice to have as a reference. You will want some access to integral tables for some of the stuff. I should have some here in the modules.
You do.
Um, they're at the very end. And they're the same ones that I gave you guys in Quantum 1, those of you who took Quantum 1 from me. Um, by and large, if you run into an integral that is not on one of those integral tables when doing a homework in upper level undergraduate physics, odds are pretty good that you've gone wrong somewhere. The homeworks tend to be tailored so that when you get to the now I have to do an integral part, if you have to do an integral to solve it, they tend to be standard forms or something that you can reduce to a standard form. They may or may not be on that set of integral tables, but like the CRC Handbook of Chemistry and Physics has integral tables. I actually have a couple books floating around in here that have integral tables, and it's like, here's the 160 different standard integrals in some sense that end up in your problems, you know. Participation wise, like there's not really a participation grade. So, welcome to upper level physics, right? I actually did away with it even in my lower level physics courses this semester. We'll see how that goes for them. You guys are in physics because you're studying it. You've chosen that as your major. In in most cases, you're getting close to graduation. Um, be here, pay attention, take your notes, contribute if I ask a question, ask questions when they occur to you. Um, there's a little raise hand button that should work. Or you can just raise your hand on the video. It's not like there's a bunch of you. I guess the two of you who are not using video can just hit the raise hand button. And if I ignore you, you can just politely say Dr. Sanders, and it's just fine. um, we've got 3 tests typically. Probably about 1 to 2 chapters per test. Okay. I will require oral presentations again this semester. Um, and then there's a final exam. Now, the oral presentations is something that we have some flexibility on, in as much as I have in the past required sometimes 1 and sometimes 2 for the course. Now, you guys, well, Chip and James, you've both done oral presentations for me. You've both seen what kind of score you get on oral presentations. They're not they're not, hey, welcome to the Nobel panel. This is my acceptance speech and lecture, right? It's like a 12-minute presentation with 3 minutes of questions. Most of the questions are coming from either your peers in the class or people in other related classes, or this time around I convinced a lot of people from general physics 2 to show up, and they were mostly nice questions. There were maybe a few that were not, but they're easy grades. If you guys want, we can do 2 oral presentations each. If you would prefer to have one and just 3 exams, that's fine too. Obviously, you have to put more work into putting oral presentations together if we do 2 each. But um, also, that means that they're weighted more of your grade. So you don't have to tell me now or anything. Let's wait till we've made it to the first exam. If we take the first exam and it's an absolute dumpster fire, then maybe everybody says, yeah, we'll take those extra presentations so that we have, enough to balance this out. And if that first exam goes really well and you're all like, hey, we're good with these grades, my goal was a B and I made a B plus on the exam. All right. Or my goal is an A and I made an A minus on the exam. All right. Maybe we don't need to have extras. So I'll let you guys think about it. Um, for Nathan, the last time that we did these,
Mhm.
I basically just checked out a room for the day, and Quantum did them. James did one for his independent study project, as it turns out, and Optics did it. That was this last semester. We did it, maybe we did it the last Tuesday before finals. We didn't have class that day. It wasn't an in-class day. It was just kind of a special day that we had the room for this day. So we're going to do these on this day. And um, we did them all in person. We had a live audience. My hope this semester, and I will try to remember to ask a little more in advance of the chemistry people, is that we can just make it a chemistry and physics day, short presentations day, that some are from this class. James, if you are continuing to work on a project with me and you want to do a presentation for that, in addition, you could. If you have an independent study class that you take and there needs to be one of those, then that could be on that day. If anybody decides, hey, I'm working on this project with so and so, and we've gotten far enough along that we've got something we could present and you want to practice it, that's a good day for it. And then hopefully the chemistry people will have a few research projects, like student research projects that they can present on as well. And so it'll feel like a mini conference almost. Last time I was even able to spring for coffee and donuts. Well, coffee and cookies. Um, so we'll see. I think if we do one, then that will be the one. If we decide that we want two, then the second one can just be like in class or something. Um, so that's your grade. The 4 or 5 items here is 75%. The finals the other 25%. The finals weighted more than any one thing. Um, and this is a smaller than normal class for me, but it's not like that much smaller. Like I've had classes with 4 or 5 for quantum 2 before. So I don't have very good statistics on how people have typically done, but if you combine with quantum 1, it seems to me that basically all the tests tend to have pretty stable averages. There's usually one random test among the first 3 that just, that was the day that nobody had it. And there's usually one where people do a little better. But again, that's just averages and small sample sizes. How much conclusion can we draw from that? Um, the grading scheme is the one that I usually use. So 85% for an A gives us a little more wiggle room. 70% for a B, 60% for a C, 50% for a D. Uh, I don't think I've ever had anybody take quantum 2 and not make an A, B, or C. And I don't even remember if I've had many in the way of C's. All right. It's it's not that I'm setting out to like give everybody a present of here's an easy class. It's just you guys are high enough caliber students that you rise to it, and that those are the typical grade outputs. Um, Quantum one is pretty similar. It's most people make A's, B's, and C's. I think I had one person one time put no effort in and fail. But it was like I think everybody saw it coming. The student saw it coming. I saw it coming. Everybody else in the class saw it coming, and he dropped before failing
Mm.
because we all saw it, and he recognized that this is where it is. But you guys are gonna make A's, B's, and C's. Probably A's and B's. Hopefully A's and B's. Hopefully A's. You can all three have A's. If everybody earns an A, I won't curve it down. Um, our final exam time is at 8 o'clock in the morning on Tuesday, May 7th. We'll stick to that time even if we go independent study, just because you guys should all have that time block free for finals, because you know you're in this class now, and I don't think any of you's double dipping. None of you's taking a math class also at 11, right? Or whatever, EET, or really those are
Yeah,
your only
no.
options. You're not allowed to take an
Mhm.
elective at this time. Okay, so everybody's free at this time. That'll be our final exam. The regular exams will just be during class time. And Nathan, if it turns out that you're not able to be there on that day, then we'll just make arrangements for you to be here someday that week to take it. And if we lose the room, then we'll just do it in the conference room or something like that.
Okay.
It's easiest to do that way. That way, it's like you taking your exam. We don't have to mess with who's going where, who's coming what time. You know,
Yep.
what room am I going to? Is there a proctor? Do I have office hours? Do I not have office hours? Any of that. It'll just make sailing smooth.
Okay.
As far as like what we cover in this class, um, I've only done it twice. So what we cover is kind of an open question, in as much as I don't have good statistics on how far do I make it, because it went a little different both times. One semester I had like 10 students, and they wanted two presentations each. And we did most of those in class that semester because we didn't have the seminar day. So the upshot to that is that we had about 3 or maybe 4 weeks worth of class where it was just student presentation, student presentation, student presentation. And so I think we formally made it through this stuff and partway into perturbation theory. And then I think it was just, so what topics did people choose to present on? And so we got a smattering of the remaining 3 chapters, or of 3 more chapters. Last time that I taught it, there were fewer students and they did not want to have 2 days of presentations. And also it was the semester we came back from COVID. Um, and we made it a little farther into the book as a result. Like I think we covered maybe this, and then I jumped ahead to chapter 14, as it turns out. Um, and that's kind of how I'm expecting it to go here too. Is like we'll probably get 1, 2, 3, 4. Part of this one is 5, and then part of 14 is roughly where I expect to go. I hate to cut material, but also, there's that kind of question of, do you want to cover the whole book but not go very thoroughly, or do you want to go more slowly but you cover less of the book but it's more thorough? And I have tended to settle on the let's go more slowly, we'll cover less of the book, it'll be more thorough. And maybe if you're going to grad school and you're worried about like prelim exams. So then you go through and read these chapters and you're good to go. Um, I have set up homework assignments for most of the chapters that we would cover. Okay. Those are for practice. I'm not going to collect them. If you want to bring them and discuss them, like for office hours, something like that, you are welcome to do so. Um, I don't know if I have my answers here, but I do have like some version of an answer key for them here. I also have worked through them, but I think my work is at home at the moment. But I'm more than happy to go over them in office hours or whatever. Okay. They are not being graded though. Okay. So that's it. That's all for the logistics of the course, I hope. Okay, we've seen the syllabus, we've seen the logistics. Is everybody good with this? Does anybody have any questions, comments, or concerns?
I'm good.
You good?
Yeah.
Looks good.
Okay. Well,
When so
sure.
like our next meeting would be Friday at 11 on here again?
Yeah, yeah. Um, I will go inspect the room and see if I can get it set up. But I want to say one of those two rooms, either 228 or 226, is set up very nicely to do Teams broadcast with a live presentation in room. And if we got the room that is set up that way, I really don't mind doing it that way if that's what you guys want to do. But I have what I've found in practice is that if you have live people and virtual people, that it's difficult to see, both, or to pay attention to both sets and to know like this person that's virtual has a question right now and we should answer it. Or if I'm paying a lot of attention to that, then I'm not, getting notes, or whatever. But I can look and see like, is the room set up for it? Because if it is, then I'm cool with doing hybrid in that way. If it is not, I think let's at least try a few virtual sessions. And so let's go Friday virtually because it'll be like a full lecture day, therefore. And so we can get into the notes and see like how is this delivery working virtual? Um, do we want to do it that way, or do we want to just go to classroom and then one or two people or virtual? And again, there's always that danger that they're going to be like, well, we chose option 3, so you're an independent study and independent studies don't get their own room. We need the room for something else. Good luck.
Mm.
Which they've done before, by the way. They have done that before. So yeah, let's do this way on Friday. And then on Monday we have a holiday, so there won't be anything. And on Wednesday, by then hopefully I'll know, am I on a jury? Am
Wow.
I here? And also by then we should have clarity about what kind of class they've decided this is. I know that Dr. Wong, the guy who's sort of in charge of the scheduling for our department, said that he submitted stuff to, or was planning to submit stuff to turn it into an independent study. But I don't know if he actually followed through, whether Dr. Menon overruled that or what. I think the magic number has typically been 4 for what it's worth, but they may let us go even with 3. It's like the amount of money that I will actually get paid for teaching this class is still less than the amount that you guys paid in tuition to take the class, even with 3 people. if they count it as an overload. They're not going to say this gets to count as a regular load class, is the only thing. It's like they have a standard contract for overloads and it's adjunct pay. And for a 3 credit hour lecture for the whole semester, you get like $2,400 or something. It's like your tuition to pay for this class is like $1,300 or $1,400 each. So unless all 3 of you are on full ride scholarships, but sometimes they're just like, well, we can't afford to just do it that way. It's an independent study. If that happens, I'm effectively not getting paid at all for the class, and I think they pay me like $200 or something. But either way, I think let's do it this way until we know for sure, and then if we continue this way, great. And if they let us keep the room and all that, then we'll take the room and see if we like it more that way. We good with that?
Sounds good.
Yep,
All
sounds
right.
good.
Okay. Well, it's kind of too late to really start any new lectures because it's already quarter till. I don't mind going a little over, but I'm not. I could maybe start to set something up, but maybe more relevant than starting to set up a problem and then having to start midway through next time, which we're going to end up doing some of that anyway, is to remind kind of where we've been in Quantum 1. All right. So this course is basically a spins first approach. If you've read the introduction and preface to your book, then you've read most of what there is to be said about like why do it this way. It's nice because that means in chapter 1 you're getting to learn quantum mechanics. You're doing something that is unique to quantum mechanics, not hey, we could have maybe got here from classical or whatever. And you're doing it without overly complex math to start with. The overly complex math is necessary, and we get to that. But sometimes it's nice to get your feet wet just doing physics and just trying to understand what's the physics here without worrying about curl this, gradient that, surface integral, blah, blah, blah. All of that is also necessary. And we may get a little bit of that this semester for even quantum. But the goal has always been, let's get to the physics of it and then let the math follow from that rather than the other way around. Okay, so as a spins first class, you've been introduced to Dirac notation. That's the bras and kets. You've been introduced to operators and how they basically function with bras, kets, and really with each other. And you've been introduced to ideas like this operator corresponds to an observable. And so what does that mean? This operator doesn't correspond to an observable. Some operators don't. We will actually see some more operators this semester that do that, both kinds. I think that, if I say operator, what's the most important operator from last semester? What do you guys think it is?
The Kronecker delta.
That wasn't an operator. Come on. That was the the result of the operation. Kronecker delta is pretty important though, yeah. I think the Hamiltonian's probably the actually most important because it's the one that we're going to see a lot of. We saw it with spins but you see it in problems that are not necessarily spin or even angular momentum problems. Okay. The spin operator is very important for dealing with spin. They're also nice for introducing, other, angular momentum, that kind of thing. And the first thing that we're going to do in this semester, chapter 6, is look at unbound states. Okay. So we're going to still have a Hamiltonian operator within our system. This is particle over a box, for example. What do I mean by particle over a box? So you maybe have a finite potential well, but now you have a particle whose energy is higher than the well potential. Okay. You can also have barriers. So basically like an inverted well. And again, unbound means you've got an energy that's higher than that barrier energy. So what happens? There's still an interaction. You actually get transmissions and reflections off of it. But we start again with the Hamiltonian equation. Okay. What's the Hamiltonian equation? What's the energy eigenvalue equation? Hamiltonian operator operating on eigenstate, specifically energy eigenstate, gives you energy value times your state. Okay, that's an eigenvalue equation. Some other things that we saw over the course of last semester. Well, we had continuous and we had discrete variables. Okay. Sorry, my cord got a little tangled here. We had continuous and we had discrete variables. What's an example of each? Well, a discrete variable was like spin. You had two possible spin values, or three, or five, depends on what kind of spin system you have. Maybe you have a spin half system and there's two possible values, plus a half, minus a half, up, down. Maybe you have a photon, which is a quasi spin one system. Why is it quasi spin one? Because it gives you values that are spin one, but it turns out that as far as we know, there is no spin zero photon. Okay, there's spin plus one or spin minus one, H bar. But you could have an actual spin one system where there's zero as well. Those are your discretes. Continuous was more like the wave functions that we got to when we finally were doing particle in a box or particle in a well. Okay, the instead of an eigenstate being a vector, we might call it an eigenfunction. Your textbook still calls it eigenstate and sometimes even eigenvector. You really have three terms here. You have eigenstate, which is sort of the overarching thing. You have eigenvector, which is probably most easily describes a discrete. And you have eigenfunction, which usually describes some sort of a continuous. For some reason, your textbook doesn't like to say eigenfunction. He likes to say state and he likes to say vector. My memory is a little foggy on this point, but I don't recall his avoiding saying um, eigenfunction when I took the class from him in person. Um, but maybe he did. So that would be some important stuff that we've covered. How does an operator operate on a state? And what does that look like if it's a vector? And what does it look like if it's a function? What does normalization look like? What is the important condition that we have for a basis set? What are the three conditions? They have to be orthogonal to each other. They need to be normalized, so orthonormality, and you need a complete set. It has to be a complete state. All of that still applicable here in quantum 2. Okay. How do we do time evolution? We apply the Schrodinger basically we apply Schrodinger's equation, and then you do Schrodinger time evolution. So you find your energy eigenstates, and then the energy eigenvalue becomes sort of like a phase term. That times time divided by h bar becomes your phase terms to multiply your eigenstates with. All right. So that idea continues this semester. Um, I think that we are running up against the clock. When I set these meetings up, it only gives me half-hour interval chunks. We could say we started a couple minutes late because of the snafu on like making sure everybody knew to be here. And again, I apologize for that. But we're about at the 50-minute mark um, since like starting. So let's call it a day there. And when we come back on Friday, we start the notes. All right. So I'm going to stop the recording.